Welcome back. Happy Monday to you. Today we're going to talk about common logs and natural logs. So two that our calculator can do a lot of the work for us. That's why we need to learn these ones. So first off, common logs. It's any log with a base 10. So for example, in exponential form, 10 to the second power equals 100, which is really commonly used for things like scientific notation. We really use that idea of tens with powers on them. Well, it would equal log base 10 of 100 equals 2 is how you'd write that as a logarithm. But because 10 is considered the common log, we don't write the little base 10. And instead, we just get log 100 equals 2. So if there's no base number written, then it is considered to be a base 10. Again, called a common log. All right, so for example, 10 to the third power really equals 1,000. If you write it as a log, instead of writing the base 10, again, we just don't write that little base 10. We leave it out. Log 1,000 equals 3. Now this is one of, again, two bases that your calculator can do for you. We'll learn about the other one in a few minutes. All right, so let's do some examples. So first off, it says log 100. So what that really means is this. I mean, we don't see the base 10 down here, and we don't necessarily see the equals x. But if I rewrote that as an exponent, that's what it is. 10 to the what power equals 100? Well, the answer should be 2, right? X should be equal 2. But your calculator can do this problem. So if you get your calculator out, and there's a log button on there. Again, if you don't have a log button on it, you don't have a good enough calculator. For our school ones, that button's over there on the left next to the 7. So if you hit log 100 equals, and you get the answer of 2. Shoots it right out for you. All right, next one, same thing. Again, we don't normally write the little 10 or the equals x. And what's really happening here is that we're trying to say 10 to what power equals 50. Well, I don't know. There really isn't going to be an answer I know off the top of my head here. I don't know. 10 to the first power is 10. 10 to the second power is 100. So somewhere in between 1 and 2, 1 point something. But again, if I got a calculator, and I just type in log 50 and hit equals, I get 1.698. And I don't really care how many decimal points you leave. Just leave some. We could have rounded that to 1.7. That'd have been fine. All right, same thing on the last one. We don't write the little 10 or the equals x, because we don't want to rewrite it as 10 to the x power equals 2. But because I don't know what that is. I don't know 10 to the what power equals 2. Well, I mean, 10 to the first power equals 10, so it's going to be something smaller than 1. When I get my calculator, can find it. If I just hit log 2, I get an answer of 0.3. So again, calculator can handle this for us. It's, again, a great way to find some missing numbers on things we would never be able to find by guessing and checking. The one in the blue at the top, we could do that one, but all the other ones came out weird. All right, so what's the other one we can do on a calculator? Well, it's called a natural log. It's any log with base e, which is Euler's number. And yeah, that's weird that guy's name is pronounced Euler. Euler's number is something we kind of skipped a little bit last week when we talked about compound interest. We never talked about what's called continuous compound interest, where it's basically compounding every second of the day and not like once a month or once a year. And we don't use this very often, but it's definitely used sometimes. And it's called Euler's number. Think of it kind of like pi, just a common number that comes up in math, higher level math, not necessarily little kid math. So again, we have what's called a natural log. So an e squared is approximately 7.398, or 389. Wow, I can't even talk. 7.389. Again, that's 2.718 squared. This is just Euler's number, E. And then we use this natural log notation. And again, you can see the little star. We use ln for logs that are natural instead of log base e, because that's kind of weird. It almost looks like log or log, and you just drop the e too low. Because that's why they've switched it. It was too much confusing with words, so they switched to ln. But again, it's the same stuff. It's just weird because it's not a number you're going to be very familiar with. All right, so again, ln e to the second. What that is missing is it's missing the base e and the equal to x part. So then we can rewrite it. E to the x power equals 2. Well, again, e is like this 2.71 number. It's kind of weird. So thankfully, our calculator has it all stored, and I just type in the ln, which is right below the log button on my calculator, and it gives me that my x number would be 0.693. Now the next one, natural log. Again, we're not writing this little base e. We're not writing the equals to x. And what the problem really is e to what power equals 50. And again, this would be useful if you were an accountant. People that dealt with money a lot use this Euler's number. So again, thankfully, the natural log button on my calculator, I just hit natural log 50 and I get the answer. The answer is 3.912. All right, last one. Again, I'm not writing that little base e. We're not writing the equals to x. It's there, but we don't write it. All right, so what I'm really going to do on this one is just type in ln 100 on my calculator, but really what I'm trying to find is e to what power equals 100. All right, so ln of 100 on my calculator, that tells me my answer would be 4.605. Notice I'm going with 3 decimal places just because that seemed like plenty. I don't think we ever need to go any more than that. Normally I'd say even stop at 2 because the most common use of decimals in the real world is money, and we would use 2 decimals for that. Alright, so if you have a calculator, this should actually go pretty quick today. It's more about understanding where these new symbols and terms come from, especially that first one, the common log. We're going to be using that a lot in our work over the next week. Alright, good luck today.